Okay, good morning, everyone. Welcome to the 2022 Solar Decathlon Design Competition. Y'all have worked so hard to make it this far, so congratulations. Based on the semifinals competition, we have 10 finalist teams that have made it this far. So again, congratulations, you're all winners in my book. At the end of the day tomorrow, we will announce the top 3 teams that will advance to the build competition. So make sure you stick around for the award ceremony tomorrow. Just a brief overview of events today. We're going to go through presentations up until 12. Then we have lunch at 12 o'clock back in the cafe. And then we'll meet back here at 1. We'll resume presentations. I believe we wrap up at 4. And there is a networking event with appetizers in the cafe. Definitely go check it out, make some friends, and relax a bit. So just a couple reminders for the virtual attendees. Please stay on mute with your video off unless you are presenting. You can use the chat box with any questions. That doesn't apply to you, Elizabeth. Keep your video on. We'd love to see you. For those of you who are here, please keep your cell phones on mute and pagers on silent if you still have pagers. I don't know. But yeah, please be courteous to each team as they present and just try to be quiet. Again, you'll have 8 minutes to present. There's an analog timer right here. As soon as it goes off, it buzzes very loudly and I will rudely have to cut you off. Followed by 15 minutes Q&A with the jurors. So with that, I believe I will introduce our jurors and then we'll kick off our first team, which is NC State University. So let's start with our virtual juror, Elizabeth Turner. She is an architect with a passion for finding synergy to create thriving, equitable communities that depend less on the purchase of energy, saving both operational costs and carbon emissions. She founded Precipitate in 2017 to explore emerging methods of holistically integrated design at the intersection of architecture, research, and education. She is a certified Passive House consultant through the Passive House Institute, US, or FIAS, and teaches project-based sustainability courses connecting undergraduate students in support of communities. Elizabeth volunteers extensively with the American Institute of Architects, AIA, Minnesota, advocating for public policy with a focus on equity and inclusion towards truly sustainable communities for all. She is a 2020 recipient of the Energy News Network's 40 Under 40, recognizing her leadership in the transition to a clean energy economy. So please join me in welcoming Elizabeth. Laura Dwyer, she leads new business development for DuPont Performance Building Solutions, a Fortune 500 material and building science supplier to the construction industry. Her career has been focused on improving construction methods and includes innovation and marketing leadership roles, as well as leadership of the DuPont Building Knowledge Center, an international network of experts who help our industry build better structures. Laura knows that active collaboration is key to change and is currently vice chair of the National Association of Home Builders, NAHB, Building Systems Council, and supports NAHB's Professional Women in Building Council. Laura also serves on the Building Institute Board of Advisors for the Housing Innovation Alliance and is past chair of the Home Building Institute and past member of the Energy and Environmental Building Alliance, Executive Board of Trustees. She has a Bachelor of Science in Chemical Engineering and a Master of Business Administration. Join me in welcoming Laura, please. Next, we have Nathan Carr. Nathan works as the Business Development Manager for Energy Logic, an applied building science company that partners with building professionals to create better homes that are efficient, healthy, and resilient. Nathan works with builders up and down the Colorado Front Range to work through the details of energy code and program compliance as a former home builder. Nathan thrives helping other home builders find unique ways to cost effectively improve their homes and increase their energy performance. Welcome, Nathan. Finally, we have Sue McFadden. Sue is an engineer and economist passionate about energy efficiency and climate change solutions. Several game-changing projects she has developed are the first leadership in energy environmental design, new construction or LEED NC, Platinum Office Park, and the first LEED EB or existing building, and a DOE Grand Prize Housing Innovation Award winning 2016, 2018, and 2019 Zero Energy Residential Development in Fort Collins. She is currently a Colorado Governor's Fellow and an alum of the National Renewable Energy Executives. She served on the Fort Collins Housing Authority Energy Board and many climate and environmental justice boards and committees. Her credentials include LEED AP and Certified Energy Manager, CEM. Susan earned a Bachelor of Science in Chemical Engineering from UC Boulder, as well as a Master of Science in Chemical Petroleum Refining Engineering and a PhD in Mineral Economics from the Colorado School of Mines. She's an avid adventurer and visits several new countries every year, exploring new countries and the natural beauty. Join me in welcoming Sue. So with no further ado, I will welcome our first team, which is Tennessee State University. A couple things for all teams to keep in mind. I've marked 2 X's down here. That's basically the range that the camera will grab you. So try to stay within the X's if you want to be on camera, that is. So Tennessee State, are you here?
Yes, sir.
Yes.
Oh, okay, perfect. They're all right. So Jack, if you all want to request control of the slides, we can go ahead and do that for you.
Yes, that would be great.
Or is there someone that you would like me to give controls to?
You can give them to me, Navarius Thompson.
Navarius?
Yes, sir.
See that? Navarius, you want to make sure you can go through the slides? Navarius, are you able to access those slides?
I'm not. Do I need to request?
No, I've given it to you. Try it one more time.
Yeah, it's not letting me advance. We're fine with you guys controlling it though.
Let me try to give it to someone else. Hold on.
Okay.
Alexander Daniel?
Yes, sir.
Oh, I think that
I'll give it to Doran Searcy.
SCH stands for something. Oh, I don't know. It's from there.
Okay. Doran, you want to try and see if you can?
Somebody.
That might have been me. All right, well, in the spirit of time, I will just go ahead and let me know when you're ready to advance slides and I can do it on my end. Is that all right?
That's fine.
All right, your 8 minutes begins now.
All right. Good morning, everyone. We are the Tennessee State University's engineering group, and this is our net zero shipment container home. You can go to the next slide. You can advance. My name is Navarius Thompson. I was a team lead and I was a part of the architectural and structural team. And the rest of my team members are here and they will introduce themselves as the slides prolong. You can go on. Brief overview. We'll start with the structural and design team, going over the site analysis, the renderings, and then the architecture. Then we'll move to the mechanical team that will give information about the HVAC systems, and then we'll finish off with the lighting and power team that will give information on the solar, electrical, and then finish off with the cost analysis. Next. Once again, my name is Navarius Thompson, and my partner was Alexander Daniel. We're part of the architecture and design team. Next slide. So a brief information about the site. The site is located at 60728 Nashville, which is about 5 minutes away from our university. The lot size itself is approximately 8,000 square feet. And to fit in with the rules for the new housing division, we ended up building 2 units at about 1,400 square feet each. And we gave ourselves a budget of $300,000. And the target audience, the lot was previously used for single family homes. And since it's so close to our university, we wanted to have an option for renting, things such as Airbnb usage. And the zoning codes, the lot is right now in the codes of RS5. Next slide. And here are some final design renders. All of our work was done using Revit as far as the design and the rendering. The top 2 images show one home, and then the right image shows both homes side by side. And then the bottom images show interior designs. The bottom left shows how we put most of our glazing windows on the south facing side to get a lot of the natural solar gain within the home. And then the bottom image also shows the interior design of our master bathroom. Next slide. And here's some continuation of the renderings. We have the kitchen and we have the living room at nighttime, and then we have both of the bedrooms, the master bedroom being on the left, and then the bottom right shows the extra bedroom that we have. Next slide. Here we have a call out. So for our wall, we ended up doing a spray foam installation within the home that gave us, and then we use a installation, our value ended up being 25 for the wall, and that also showing how we connected the roof to the container homes themselves. And with the container being so short, we ended up doing a roof that was attached on top of it and not insulating the roof on the inside. And for the installation for the roof, we ended up having an R value of R30 using blanket installation. And we topped that off with asphalt shingles. We go to the next slide. And here shows a foundation section. We chose slab on grade, insulated, and the R value for the installation for that was R19. And the interior ended up being R25. Next slide.
Hello, everyone. My name is Alex Daniel. I'm the second member of the architectural team. So here are some of our load calculations for each of the zones within our home. We have zone 1 being the kitchen and living space, zone 2 being bedroom 1, and zone 3 being the master bedroom. And from these values, we figured out where the heat gain was in the house, and this helped determine the material selection that I will get into in the next slide. So we decided to decide on triple glazed windows for our windows throughout our home because they are very energy efficient and they're just a great sound barrier to use being on 28th Avenue. And then we went with a fiberglass exterior door also because it is very energy efficient and a poor conductor of heat and electricity. Next slide, please. And then this is our overall construction cost, not including the mechanical and electrical components of our project, totaling out at a little over $217,000. Next slide, please.
Hello, I'm Whitney Whitfield, part of the mechanical team. Please advance. So here we chose ductless mini split heat pumps because it transfers electricity into 100% heat. And we also got a tankless water heater that basically has water on demand. Advance, please. Here are our mini split systems. We chose the quad zone heat pump for 42,000 BTUs and also our Raheem tankless water heater that is 100% electric. Advance, please. Here are some of our mini split system specifications. The cooling BTU is 40,000 and our heating BTU is 45,000. Advance, please. And here are some specifications for our Raheem tankless water heater electric, the RTX 18. Advance, please. Here's some more specifications. Advance, please. Here's the last specification. Advance, please. Here we have our mini split connections throughout the house, as well as our water connections with the water line meter connection being yellow that's connected to outside of the property to our main tankless water heater. Next, please. Here's our water flow. We do have a slender roof that helps with water runoff, and there's the location of our current rain runoff site, and also the location of our water meter. Advance, please. Here are our ventilation system connections, as well as our drain and wastage connections. Advance, please.
Got your 2-minute warning, Whitney.
And then here we have our water pipes, our ventilation duct system, and also is our drainage wastage pipes connect. Advance, please. Here we have our Tennessee frost line, which is 12 inches. Advance, please. Next, we have our underground plumbing where our water line should be buried as well as our sewage line. Advance, please. And here are our 4 house zones. Advance, please. Next, we have our zone loan calculations on the next 4 slides. Advance, please. Advance, please. Advance. Ty.
Okay, so I'm the lighting team. My name is Ty Rivers. Next. We use solar panels for the power. The house needs 16,000 watts, and we use monocrystalline panels. Next slide. Next slide. So different parts of the house use different percentages. These are the percentages. Next slide. These are the lighting fixtures and where they'll be placed throughout the home. Next slide. And these are the switches, outlets, and wiring, and where those will also be placed throughout the home. Next slide. This is the cost analysis, which is about $35,000. Next slide. These are the appliance spec sheets. Next slide. And this is a continuation of that. Next slide.
So to wrap things up, before PV, we ended up having a HERS score of 64, and then after our design, we ended up getting 18. And the total cost for the home to build was around $252,000, and that's about $50,000 under our set budget. And that's it.
Thank you.
Okay, we will now turn it over to the judges for 15 minutes of Q&A, starting now. Y'all can go ahead and speak right into your mics.
Okay. Hi. I love this project because it's economical and it shows, what we can do with energy efficiency and still be affordable. So good job of looking at the containers, and I like the flow of the house and the daylighting that you provided through the curtain wall. I guess my question is more about like the HERS 64 and the HERS 18. The project was supposed to come in at below 45. How would you, if you were looking at this again, what ways could you get the initial HERS score below 45 so that then your after PV could get to net zero? Do you have any ideas looking at it in retrospect?
I think to answer that question on a structural standpoint, a lot of it had to do, I think, with the orientation of the build, for one. And then also, I think our base design in the beginning, we had a lot of different iterations, trying to fit in an aesthetic look to fit in with Nashville. And also the location that we chose was a little bit harder because it is a different types of building styles going up there. So I think the design that we went with, choosing those big curtain walls, and then also, like I mentioned, the orientation, and then also having to deal with some of the zoning and coding that the design wise, I think would furthermore impact the before PV score, I would say.
Great. Other questions?
Yeah, I have 2 questions for you. One, I guess, is more design related. I do love the design of the home, but looking at those large curtain walls, do you have any concerns about privacy from the street, any home buyer acceptance issues around that?
Yes. The house is located right off of 28th and Georgia Street, and off of 28th Avenue, it's a lot of new homes coming up. And the question for the big curtain walls, I had the same question when we were designing. What would be a issue within privacy? And we didn't implement it on this design, but we did want to show how we would have, cover those issues by putting up some, blinds, daylighting, shading techniques within the home, but we weren't able to show it on our example.
Thank you. My other question, I'd love to hear a little bit more. It looked like you were using a tankless electric water heater. And I'd love to know more about the decision to go to that and if you considered using a heat pump water heater instead.
Yeah, so we chose the tankless water heater foremost because how energy efficient it was, but also the spacing. So instead of having like a big gallon tank water heater, we chose a smaller one because when you're dealing with a tankless water heater, instead of just holding that water, it gets basically the water that you need in advance. Of course, it does have disadvantages, meaning like you can't take, two people can't be running the sink and have a shower at the same time. But to keep that energy efficiency, it's mostly like instant. And then again, it saves a lot of space, if that answers your question.
Thank you.
Hello. I just first wanted to say I loved your video. It was super creative. So thanks for that. It was fun to watch. I had some questions around the envelope itself. I'll start with foundation. It said slab on grade with R25. What type of insulation were you going to put in that? In the foundation?
I think it was that insulation. A lot of the work we did, like I mentioned before, at school we have a capstone 1 and capstone 2 class, and we use the competition as the work done for it. So to balance both, we did most of our preliminary designs that came over, which is the first semester. And the second semester we did capstone, which is based on the other design. Working with our professors, we used a call-out sheet that we created on AutoCAD and Revit. And I think, if I remember correctly, when we put it in the system for the energy rating system, it was bad insulation. If that answers your question.
Yeah, it just says you think about slab on grade, that probably is going to be a tough product to put in there. You probably need to do some type of rigid insulation so that when you're creating that foundation system, because bats can get compressed. And I'll pause there and see if there are other questions.
Yeah, we got plenty of time. We were
Yes.
just,
Online.
oh, excuse me.
Yes.
Elizabeth.
Like when do I jump in? Yeah, I am curious about the use of shipping containers. If you can say more about that. It looked like from the floor plan that the floor plan isn't like a standard size of a shipping container. Were you thinking you would kind of take the shipping containers apart and just use the walls? And can you tell me more about why you think that the shipping container is a good fit for this project?
So we did use 5 shipping containers. We didn't show it on the slides, but we ended up using 4 40-foot containers and 3 20-foot containers. And initially we ended up doing just a regular home design, but after speaking with a lot of our advisors and people who helped us on the project, our advisor mentioned why wouldn't we want to implement some kind of eco-friendly design. And so that's why we went with using the shipment containers to help, stand apart from a lot of the other designs. And once again, just not only trying to reach net zero, but also implementing some kind of eco-friendly design standpoint.
Okay. And then
I was going to
yeah,
add
go ahead.
also to that question, here in Nashville, we really don't have that many type of like housing that looks like shipping containers. They're mostly like tall and skinnies. So we thought that would be like kind of out of the box and different, especially for Nashville.
Can I ask another one?
Sure.
Yeah, so I think like I can definitely see this fitting in with like the cool aesthetic of Nashville. I love the aesthetics of it. And I have some more questions about those curtain walls. Did you look at any options that the windows were smaller, and how did that impact your energy use?
Yeah, so we did a solar study on using Revit and determine the size of the windows and the panes that we use, kind of help target how high or low we were getting away from net zero. And another thing that really helped change the values were the pitch and the roof that we had from our shading techniques. And we thought that having more on one side than the other, rather than having bigger windows, have a better shading technique, or smaller windows and have a different roof style. And I think that's why, and then also, like I said, mimicking or trying to recreate some of the building styles that was around the light those houses kind of mimic or have those bigger curtain walls and open areas.
I also just wanted to add, like, the choice for using the curtain walls also has to do with lighting. We were trying to get as much natural lighting as possible in order to not have the person that lives there to bring in so much, making our energy source can be a little bit lower for usage.
Great, thank you.
I had another question. I do want to say too, I'm a Nashville native, know the area you're talking about, have seen, going back to visit family, seen the amount of gentrification going on in this and other close by neighborhoods. So I appreciate, looking at a way to keep current residents in the area while also increasing density. Wanted to ask about this just because it will be a big impact in the overall project. Did you look at land costs and what, current pricing, assuming that there's currently a lot of scraping, rebuilding, putting in those tall, skinny 3-story lots. How did that impact your design? And did you take a look at what that lot would have cost to purchase?
We actually didn't get a pinpoint number because the lot is actually owned by one of our professors' family members. So that was one of the reasons that we chose it. But before that, we actually chose a bigger lot that's right beside it. And we used a Metro Parcel Viewer, and we just saw that it was already picked up by a big company. So we just left it alone. But I do understand where you're coming from as far as the price would impact our total bill cost. But I think that was one of the biggest reasons that we chose the lot that we did, because it was, I guess you could say, family oriented. And
also with that question, although we didn't look up the current lot sizes, I did do some research on how much an average house could cost to build in Nashville, and it was a little bit pricey. So like it was kind of like around $400,000. Well, that was like the average price home in Nashville, like a regular single family, multi-family home. And then also to cost to build is kind of around like $400,000, depending on the area as well. So I thought for us to have a shipping container energy efficient home for $252,000, that's a steal. Well, to me, kind of. So
Absolutely.
We still got 5 minutes for questions, if anyone else.
I have a question on the solar. I don't know if it's 10 or 16 kilowatts you have for $14,000. Seems like super cheap, but including a battery. 16 kilowatts? That's
Yes.
a lot for a 1,400 square foot house. What was the value of the battery if you weren't getting to zero? When did you use the battery, and how did you think that was economical?
Well, it was based on like both of the houses because we were building 2 houses next to each other.
So the battery was used by both houses, and the 14 kilowatts was or 16 kilowatts was for both houses?
No, it was just for one. But basically, so a lot of the energy came from the HVAC portion of the home. So because a lot of it is going to be all electrical, so that was really where most of the power is coming from, and why we needed such a big battery for that.
But were you load shifting, or?
Were we what?
You were load shifting? It seems like you're still taking a lot of power from the grid.
Power from the grid is solar.
But you're not net zero. So you're still getting some energy from the grid? You're at curves of 18?
Yeah.
I guess it comes down to what is your utility costs in Nashville, or where you're at.
I'm not 100% sure on what the actual utility cost for Nashville is, but I just know when I was calculating like most of the power that was needed for the home, a lot of it was coming from us having to power so much of the HVAC and just everything being electrical. So that was really where a majority of that came from.
Thank you.
Yeah, one of the important factors for making sure that your structure is going to deliver the performance you're hoping is to make sure that you have good integration of all details around the building envelope, because that's where I focus all the time. And one of the things I didn't see in the submission, but something to consider as you do designs is the integration of penetrations. Like, so I didn't see any detailing around how you're going to integrate windows and doors and pipe penetrations. How you deal with those could totally impact the energy performance of your structure. So just something to consider as you think through designs in the future.
And we have just about 1 minute. If there's one last question we want to sneak in from the jurors.
No, will say I do a lot of energy modeling in my day-to-day life. And I'd just caution taking a second look at your inputs. I think you've got some opportunities to review those inputs, and looking at that, I think your energy consumption might actually be coming down. So I just suggest to take a second look at those. But no, overall, great project. Really appreciate the focus on Nashville.
And with that, let's have a round of applause for our Tennessee State team. Okay, thank y'all. Next up, we have Ball State. Is Ball State in the building? Awesome, come on up.
So again, you can keep an eye on the time here. He'll also give you a warning when you've reached 5 minutes, 2 minutes. And time. These will be yours to control the slides. You can also reference there. Maybe want to check if you can advance. Perfect. Just give it a second for jurors to maybe wrap up their last few thoughts and then. We are way ahead of schedule. Yeah, that's right. The X's. Yeah. I'm sure that's one of your top priorities, right? With all the things on your mind right now. 5 more minutes. I hope that the anticipation isn't killing you. You have any funny jokes?
I thought the same as we talked a little bit.
Yeah. Y'all get some rest last night?
Oh my gosh.
Actually,
I
yes.
was knocked out as soon as my head.
Yes.
Us two flew in like at 7:05. So we woke up at 3:30 and so we've been up that whole time. So as soon as
So yesterday was a long day.
Yeah. 7:25 a.m. Yeah, those are rough flights.
Yeah.
Yeah.
the flight was pretty quiet.
I thought you said-
We had a really nice flight attendant. She was making a lot of really good jokes. She said something like, I guess you can't drink on the plane anymore. She said, make sure you guys don't bring any drinks out. It'll be a $9,000 fine. And she said, but if you do want to make that risk, I'm single. That means you're in my
You're in my
type or something like that. And I was like, I bet.
I think they don't allow you to bring your
Alcohol.
own alcohol.
Yeah.
Yeah.
They used to you could bring little minis because they're less than whatever 3 ounces.
Yeah.
Or whatever. Yeah, don't have too much fun. You should have.
I just want to jump in quick before you get started.
Yes, Elizabeth.
I cannot hear people who are not right next to the mic.
Okay.
Okay.
So if you're the person speaking,
Are
if you
there-
could move around and stand right in front of the mic,
Are there
that would be helpful.
are the wireless mics working behind them as well? Is that another? opportunity, or do we want to just stick with that one mic? Okay, okay. Nope. Thank you, Elizabeth, for that information.
Thank you.
That means they missed a good joke.
Exactly, we got lucky.
Yeah.
Yeah, I want to try talking again. We'll see. You don't have to, like, maybe you say something, Emily. Hello? Is that better, Elizabeth? Yeah.
No.
So she's still struggling to hear. Is that the highest? Okay, so you gotta get a little close to it.
Can we take it off?
Sure, yeah.
Okay. I have no issues. Oh, try speaking into it and you'll be first. So let's test it.
Can you hear us?
Oh yeah, that's so much better. Thank
Okay.
you.
Thanks.
Thanks, Elizabeth.
Excellent, thank you.
Okay. Jurors, are you all set? You want to do a quick bathroom break? If not, we can get started here in a bit. Okay.
Yeah.
Good. Elizabeth, you ready? Okay, Tennessee State, take it away.
Oops. Ball State.
Ball State.
That was the last team, right?
Good morning. We are Ball State University's new housing group under the roof, and we are all fourth-year undergraduate students. My name is Emily Burge, and presenting with me today are Rebecca Booker, Claire Slaughterbeck, and Kitora Mendoza. Before we start, on the left hand of your screen, you will notice a bar that will address all of the contest areas during different sections of our presentation. Our design, 52 South LaSalle Street, is trying to create a high-performance, high-quality, affordable design for Englewood families. It is a combination of private and shared space, creating two separate units to fit the needs of every family dynamic. It will stand out in the neighborhood with its new material palette, but fit within the existing neighborhood with its gable roofs and three-season porch, all while being a net zero energy home.
As Emily stated, we are actually located in Indianapolis, Indiana, more specifically right under Washington Street. This is really important because it's on a main road that directs right into Indy, so mainly a commuting road. But the intention here is to kind of adapt some of these values that Englewood CDC, an organization helping to revitalize the neighborhood of Englewood. We want to make sure we are kind of doing what they are doing. And so their focus is to bring families back into the community of Indianapolis. Indianapolis is actually doing a lot of community development there right now to try to, bring the situation back up, make sure we're not displacing people at the same time though. So that was what our intention was as well. And we also want to utilize the Blue Line bus stop that is being added to Washington Street, again, the main road.
So the first step in our design process was to create a typical duplex, but we found that our site was very small, and so this would not work. Our site is only 27 feet wide, so we had to play with the form in order to get the floor plans to work. So in order to do this, we took the party wall and we pushed it back and forth to create wider spaces for the living room and kitchen. And then we pushed the second unit back to create variation, and then also creating space for a three seasons porch that would create connection between the two units and a sense of community, while also having the occupants have their own private spaces that they could go to. Our home sits on a lot that has a maximum width of 27 feet. And with this in mind, we created larger living spaces by adjusting the party wall. This also allowed us to mirror the floor plan for maximum efficiency. Coming in at 1,700 square feet and 3 bedrooms, 2.5 bathrooms, these homes are designed for families of all makeups. With the extra space, as compared to a typical affordable home, the extra space will make families more comfortable and allow for families of larger sizes to live.
Something else we want to make sure we pay attention to is the shared versus private spaces, especially after COVID, being in our own spaces and being so locked up. We wanted to make sure there's opportunity to share with one another and be with one another, but not be uncomfortable. So allowing that opportunity in the three seasons porch, and then maybe even just, when you get home in your carport, but then having that private backyard space in your actual private unit to kind of give that differentiation. We also wanted to harp on our materials and sustainable ideas. So bear with me, this is a little bit of a long slide to catch up. Something that we really wanted to focus on are 4 main things: locally sourced materials, cost effectiveness, environmentally safe, and architecturally pleasing. All of these in a duplex housing is kind of hard to get all at once, right? But we wanted to make sure we could do that. So let's jump into some selections we've done. We have the SIPS panels with polyurethane, ICF foundations, and concrete-free plywood slab. We chose the concrete-free plywood slab to kind of help combat the use of concrete and lower our UI. Before it was higher, we decided to keep that. We also have the recycled cedar siding, recycled panels, recycled plastic composite panels, and recycled vertical aluminum panels. So we're doing a lot of recycled materials to try to help lower that. PV panels on the roof, and then stack ventilation from the clear story windows. Sorry, I didn't know what they said. So just trying to make sure we have those in the master bedrooms.
HVAC we selected was a ducted air source heat pump. We originally thought about doing a ductless mini split unit, but we found that the manufacturers do not make a small enough unit for our high performance home. So the ducted air source heat pump was a better fit for our home. And then we also have an ERV to go with that. We also selected a drain water heat recovery. We thought that this would be a great addition for the families that we're trying to target into this home. It would save them a lot of hot water. The hot water bills, because they have a higher demand with lots of baths for the kids and as well as lots of dishes. And so we thought that this would be a great addition for them to help save heating water. And then some highlights for integrated performance. We selected a TGI joist running through the 2nd floor so that we were able to run the HVAC through. We also have centralized plumbing and HVAC for efficient distribution, and then proper orientation of the roof so that PV panels work. And then the northeast facing 3 Seasons porch, it's unconditioned. So we thought that having this orientation here would help reduce the heat that is being directed into that space in the summertime. So it's more comfortable for the occupants.
For the energy performance slides, we have 3 different EUIs of average Indiana home, 52 South LaSalle and 52 South LaSalle with photovoltaic panels. The FIAS numbers that you can see on the right side of the screen directly influence our goal of not only creating a net zero home, but also creating a home that these families can save thousands of dollars a year in. With that said, the net result was a low load net positive duplex that saves these families over roughly $5,000 per year, which can be used for emergency money, family vacations, and even college tuition. For our embodied energy, we have used tally. And for tally, we saw that carbon dioxide and concrete was one of the main factors. And so we wanted a 5 to 10% reduction in the entire thing. After using tally as our embodied energy tool, we saw a 25% reduction.
So to sum up, our design is centered around families, creating private and shared space and fitting the needs of every family dynamic. It is located in Indianapolis, being close to the jobs, restaurants, entertainment, and other amenities downtown. It is affordable for the families in Englewood, coming in at $473,000 and $236,000 a unit. With Englewood CDC's help, families will be able to offset the costs with low income tax credits and federal grants. It is also, we also did a calculation through RS Means and our own internal research and found that it comes with a 16% premium. This premium is due to the more efficient systems, and these more efficient systems will actually be saving families money every month. Finally, our home is high performance, generating as much energy as it consumes with PV panels, making it a net zero energy home. Thank you.
Okay, we will pass it over to jurors now for questions. Take it away. You want to start?
Sure. I have a few questions for you. So you did talk about your embodied carbon analysis. I was curious. I'm a big fan of SIPs and ICFs, but they also have a lot of foam in them. Did you really take a look at how that's going to impact your embodied carbon? And did you look at, it looked like you were using a polyurethane foam. Did you look at any other types of foams or opportunities to look at that embodied carbon?
Yes, so one of the main things that we thought through when we were looking at into SIPS panels was the embodied carbon, and also I guess how sustainable it would be. And we originally thought about doing polyiso SIPS panels, but we also saw that they were really, I guess, emissive for carbon dioxide for the atmosphere. And so we were going through a specific company that we would have to go through for specific SIPS panels that would be custom built, that would have polyurethane for the foam. And then the polyurethane would be not as carbon emissive as the polyurethane, or sorry, as the polyiso.
Great. The other question I had, I was looking at your solar design, and it looks like you've got all of your solar panels pushed to one of the roofs. And I think that makes a lot of sense for getting maximum, solar collection, maximum exposure. But have you thought through how that's going to work for the two different occupants?
So it's actually on both of them.
Okay.
But there's one of those images, you're looking at an elevation image, I'm assuming. That's an old image. So if you scroll down, there's actually another one and it shows both sides. So it is on both sides. We just missed that. So apologies.
Get it.
So do they share the solar or one of them?
Yes.
Who gets the south facing solar panels?
So both of the families get the south facing solar panels, but they're split, and then the north facing solar panels are split as well. So I believe per home is 18 solar panels per, and then on the north side is 10 solar panels per unit. So a total of 28 per house.
What's that in kilowatts? Sorry, we got 370 panels.
You said for kilowatts?
Yeah.
Do you mean like the actual panel output or?
I think your report, it's saying 56 300-watt panels. So
yeah, I was just, I didn't know what, no, I knew the wattage of the panels. I just didn't know if you meant like the total wattage of like the entire output or just the panels themselves, like specifically. Sorry.
Well, I know Nathan can do this calculation. But, you give the Prius numbers, but what's the HERS ratings before pre and post?
So we don't have a HERS score, but we do have an ERI, and our ERI before PV was at 25, and then after PV was, I believe, a little bit over -1.
Can you translate?
Yeah, I saw that you're using BEOPT. I have a few questions about that, but I want to let Laura and Elizabeth go first before I dive into that.
So I really like the design. It's a cool looking design. But the thing I didn't see in the submission is how you're going to manage the water and air infiltration for SIPs. I mean, they are good panels, but you need to talk about how you're going to protect those panels. And again, integration windows. I do want to commend you because when you calculate the monthly payment, you included labor and architect. A lot of the teams just do the cost of the components of the house, but you need to consider land, you need to consider profit. So I appreciated that you guys had that additional consideration in there. And then I'm leading up to a question around, it looked like you were using SIPs and mineral wools. Who can tell me a little bit about that wall design?
So SIPs are the actual exterior walls and roof, and then in the interior, like partition walls, we are using the mineral.
Okay, all right,
So
thank you.
yes,
Okay.
and we knew that question was coming. We took it off the slides because it was always confusing.
Okay, so it's just between the units then?
Correct.
Okay, all right, thank you.
Do you have a question from Elizabeth?
Yeah, I'm curious about the kind of resiliency questions. So 2 questions relating to the SIPs. Did you consider doing a vented roof on top of the SIPs to help with moisture issues? And then do you have any concerns about the SIPs sitting right at grade level?
For the, I would say at least for the roof, I don't necessarily think that moisture was really our concern. We knew it was going to be mostly an airtight exterior envelope. And then with the rest of the SIPS panels used on the exterior envelope, we didn't really take into consideration, we took into consideration moisture, which is why we wanted an airtight envelope. So we use SIPS panels. But for the other question you asked,
Yeah, there's a detail where the SIPS panels are sitting right on top of the ICF foundation, but it's kind of at grade versus being up a few inches or 18 inches or something like that.
I think if we were to go back and do it again, I totally see what you're saying now. I think it would be beneficial to maybe raise the ICF just a little bit, especially with how Indiana has a lot of flooding with the potential of that. So if we were to go back, I think that would be something we would maybe want to change. Yeah.
Cool. And then I think it's great that you did the FIAS core prescriptive standards, like those are new and it's great to see teams using them. But I think the values, the R values and U values that you have in the summary sheet are different from what the prescription would say you need to have, and they're higher. So can you talk a little bit about that process of increasing those values and how you got to those decisions?
The values that are on the presentation slide are the exact same ones that are taken from the narrative. So I don't know about that discrepancy, but I do know that the R values and U values that are used directly on the energy performance slide directly went into our goal of how thick the SIPS panels need to be, how thick the roof needed to be, and also for the foundation and other values as well.
So the summary page is maybe just, the 2-page summary is just incorrect. Like, do you have an R83 roof?
Oh, we do have a, yeah, get the energy performance slide. So these numbers were minimum values based off of our square footage. They aren't the actual values that we used in our building envelope and exterior. I don't know if that's what you're with.
Yeah, that is exactly my question.
Okay.
So how did you get from these?
Sorry.
Yes, we'll get there. How did you get from these values that are the recommended values to then what you decided to go with for your actual values, and what was the decision-making process?
Okay.
I just love to hear more. Yep.
Okay, thank you. So for the R values for the wall and also R values for the roof, we knew that a majority of the thermal conductivity was going to be from the exterior envelope. And then also we knew that the exterior envelope was one of the main key points in getting a low EUI and a very energy efficient building. So these values that we have here from FIAS were essentially minimum values that we wanted to then increase for our overall goal of making a very energy efficient building. So I think, for instance, for the R value for the minimum wall, R value for 37, I believe ours for in the summary is at 40 or 44. And then the same thing for the roof. For the minimum R value, we have 68, and I believe ours is 83. Just to also make the tighter envelope and also just go into that full energy efficiency process. It was also the same thing with the floor foundation. With our floor foundation, with the minimum being at 18 and 24, we personally didn't think that was a lot. And then with the use of the concrete free plywood slab, we saw that we could get a lot more insulated value out of that. So that is another reason why we did that as well.
Great, thanks. And just a quick question on this slide. What are the units? Is it 9.75 kBTUs per square foot per year? Or is it 31?
These are in kilo-BTUs.
Okay.
Just a quick question. You mentioned the plywood slab. From a cost perspective, did you include labor components? Because it's probably a little bit more labor intensive to do that. I love it, by the way. I'm going to take it back and show everybody because I think it's super cool. But I just wondered in the cost estimates if that was included.
Yeah, so we did our best to estimate the cost of labor, but because of the market right now, it's very hard. So I'm not sure that there's a specific line item for that, but we did our best to estimate the labor.
Okay, great.
I'll expand a lot. Not only that, but because it's kind of a newer thing, it's kind of, who knows how well this is going to go. So the number really could vary a lot more than maybe we have shown.
I really love the architectural drawing and how you like split the house and
Yeah.
staggered it. That was really creative and really well done. As I'm a former housing authority person, so, and an economist, so I look at all the number parts of it.
Mhm.
And a housing authority can't really take advantage of tax credits for
Right.
solar. And I really wonder if somebody on $600 a month can afford a $400,000 house. That's pretty steep.
Yeah, so Inglewood CDC works with families that are low income qualified, and so they will qualify for low income tax credits and other federal grants to be able to offset the cost down to what they can afford. And then they will also be rent to own, so they will occupy the homes for a certain period of time, paying the monthly rent that they can afford, and then they will eventually be able to afford the home and live in it and own it themselves.
I like your layout. Could we go to the slide with the first floor plan? Just because I do have some questions about it. So I guess on your kind of slid back unit, you've got that front entry space. Have you thought about how that kind of entry space on the front and then space to the garage or to the backyard on the back could have been better used? I'm coming from this as a former builder on, we want to make sure every piece of square footage is sellable, usable space. And it does seem like we've got just a nice wide hallway, which could see valuable space, but what are the goals in that? And then did you think through any other designs on that? Yeah.
We definitely thought through several designs. We almost said as a joke, we said we wanted to include, I believe there was 30 different floor plans that we did. So there was give and take on each and every design we came up with, but we landed on this one. The main issue we ran into were hallways. I'm just going to call it out because I'm sure you all have seen our little hallways and the big hallways, but because the site is so skinny, it just really kind of made us had to elongate it in order to offer that opportunity to have these larger spaces. We actually had a design, one of them, where it was kind of more compact, but the rooms just got so small. You got a bigger yard, but the rooms just got so small. It was like, who wants to live here? Like, I don't even want to live here. So, it was a lot of give and take, but we definitely agree with you on the sense that there is more to be done. I think if we continue working at it.
Let me add to that also. The extra circulation space provides an entry space to put your shoes for children to play in long hallways. It also has extra storage. And our Three Seasons porch provides an opportunity, for families to interact with each other, but it also allows them to have sort of a barrier from the street, but still be outside and enjoy the outdoors.
In the submission, when you talk about SIPs, you talked about how they were more severe weather, extreme weather resistant, hurricane and tornado. And I commend you for thinking about resiliency for sure. But just caution, because how they're connected together matters. So if you don't have the connections, like don't promote it if you don't tell people how you're going to connect it, because you can have a panel that works fine, but if it's not actually secured in place, it'll fall in. So just a learning moment, just to say, hey, if you're thinking about SIPs, you got to think about what those connections are going to be and the performance. And there are actually testing standards for hurricane and tornado resistant shelters.
I guess one of the main points that I saw a video of actually for hurricane and at least like tornado testing even, where they were essentially just shooting 2x4s into SIPs panels from the side without being mounted to like any footings versus if they were. So that was definitely one of the considerations that we were taking into consideration. But another consideration that we were thinking about, at least for tornadoes and any other natural disasters, was the ICF to the SIP panel, that connection. We also saw that was really strong, and then also for the ICF forms themselves being really strong and being really resilient in that area.
Yeah, I've been there. I've been to the testing because we had a product that had a sit panel with Kevlar in it. You have to have the Kevlar in it to withstand a tornado F5. So just, they are more resistant than typical construction, but how you connect them together is, because the panel will work fine by itself, but if it's not connected in a system that's going to hold it, you're going to have a challenge. But I could totally commend you for thinking about it.
I was about to ask you what you would suggest. So
Yeah.
thanks for answering that too.
Yeah.
We have 2 minutes for questions. So if jurors want to ask a couple more, and we'll wrap it up.
Can I just say, I hope you get this built for many reasons, because it's a great model for affordable housing. But I see Indiana's on 2007 code, which is like 40% less efficient than the current code. So they really need to see really good examples, and hopefully it'll ripple through your whole industry.
Well, and I guess I did want to ask, what led your decision to use BOPT? It's an interesting program. And I say that at a national lab that probably helped develop it.
So,
Yeah.
So initially we were trying to use BOPT, but we didn't necessarily, it was a struggle to use it at first because we didn't really know exactly where the U values and the R values were really supposed to be, and where exactly the numbers were supposed to be. I remember, I think I did at least like a 9-hour just straight, just face tank, just trying to figure out how to use it, and I still couldn't figure it out. I even emailed my professor. I was like, yeah, I don't think I'm using this anymore. But we also tried to use rim rate, and rim rate seemed to be even more of a struggle. So I think the main reason that we used BOPT was I guess ease of access, because it was a little bit easier to use and it was easier to get the calculations that we needed in order for us to be net positive and net zero.
Okay.
Paul Norton is here today, and he wrote BOPT. So when you walk around,
I'll introduce you.
Yeah.
He's wonderful.
Thank you, Paul.
Right. I think let's have a round of applause for Boston.
Okay, we're going to take a quick 10-minute break, and then we will be right back here 10 minutes after the hour, because our next presentation starts at 15 minutes after the hour. So take a quick break. We'll see y'all back here in a bit. Thanks.
Great job.
Just a few minutes, we will welcome our next team, the University of Arizona Sunblock. Just want to give a last minute for our virtual juror to join, and then we'll get started.
I'm here.
Come on up. I'll let y'all know when you can begin. We're waiting for exactly the 25-minute mark, so we stay on schedule. Yes.
Jumping jacks.
Don't worry. I've been in your shoes. It's okay.
Yeah, that's nice that you have some support here.
We're not that scary either.
Some familiar faces.
I think it was you and like Mark Lalaberte.
Oh, yeah.
And Mark is not, I mean, he knows the science,
Oh
and
my
he
gosh.
is going to grill you on it. And yeah.
So for me, it's like ask at the level.
Elizabeth, are you with
I
us?
don't wanna- And I don't know.
Yeah, I've been here. This was
Okay, great.
Teach me
Yeah.
something.
Just 2 more minutes. Do y'all want to do an audio check? Make sure she can hear you.
Check.
Yeah. Good? Okay, great.
Check.
Yeah, just make sure y'all try to come up to the microphone when you're talking. And Elizabeth, if you can't hear them, feel free to interrupt at any time. It's important, obviously, that you hear them. So
sounds good.
Check.
What frustrates me about building is they know how to build. But when they are required to do it, they don't build it. You would think you would.
That's my suggestion.
I don't know why.
And
they've
again,
done that.
like, I don't know his, like, if he's brought onto a project with its, and are they developing themselves, or are they typically working with developers? And it's probably developer requirements.
Ready? Yeah. But
Yeah.
But we already know how to do it.
Okay.
You learned
Yeah.
on me.
All right, welcome back, everyone. I think we are ready to begin, so I will go ahead and introduce. This is University of Arizona Sunblock Esperanza System. Take it away, y'all.
Hello, everyone. My name is Matthew DeLong, and this is the Esperanza System, a modular alternative construction system designed to address the increasing housing demand in Tucson, Arizona. To start off, I would like to introduce my teammates. We are all in our 4th year of the Bachelor of Architecture program at the University of Arizona. Here with us today, we have Andre Skledhill, Serena Gray, and Matthew Cohen.
Let us introduce you to our home, Tucson, Arizona. We are surrounded by mountain ranges in the valley of the Sonoran Desert. While the city boasts nearly 300 days of sunshine a year, Tucson's climate is much more extreme than many think. We have relatively cold and dry winters with occasional snowfall. We also have heavy monsoon rains in the summer. In many neighborhoods, including our target neighborhood of Miracle Manor, the streets are also the storm sewers. Climate change means we're facing not only heat, but more flooding. The vision for the Esperanza system is not only for a single accessory dwelling unit, but also for propagation throughout the Miracle Manor neighborhood and into the Tucson community as an affordable and efficient alternative to traditional building methods. The units can be incorporated into every stage across the housing continuum, but we're using the system to show an affordable, small-scale solution to issues such as homelessness, rising housing costs, and lack of affordable housing that is already present in the Tucson community.
The Miracle Manor neighborhood is a lower income neighborhood with 30% of the community on food stamps and ever increasing housing prices that are pushing residents out of their generational homes. Because of the simple construction of the Esperanza system, the ADUs can provide both opportunities for community involvement through collaborative construction, as well as a chance for supplemental income and generational housing for the residents. A driving factor in this project was the exploration of a code in the city of Tucson that was changed in December of 2021. This code change allows ADUs to be constructed on every suitable parcel in the city. Designed for the smallest lot size in Miracle Manor and accounting for setbacks, the maximum width of the entire unit is 34 feet, with variations based on arrangement or preferred size of ADU.
First, the construction of the Esperanza system is inspired by U-Build's lightweight modular boxes. The Esperanza system is fastened onto a pin foundation and wood joist structure. The modules are constructed using CNC Ponderosa pine plywood. Then, using basic hand tools, the panels are assembled into boxes which form the building blocks of the system. The walls consist of 2x2 and 2x4 modules, while the floor and roof consist of 2x14 box beam modules. Second, the 4 modules are then fastened to the wood beams above a vapor-sensitive membrane. The radiant floor system is added into the modules. Third, the wall modules are then placed in a herringbone pattern to increase structural rigidity. The denim con installation is added inside the modules before the last panel is assembled. Fourth, a sulfate adherent hydrogap membrane wraps the building. This acts as both the air and vapor control layers, creating an airtight assembly. Fifth, steel Z-grit fairing is fastened to the structure, allowing the cladding system to be added, finishing the wall assembly. Sixth, flanged windows are fastened to the structure from the outside. Seventh, 1/4-inch polyiso sloped foam is added on top of the roof modules, along with a second layer of membrane. A snap block roof and C-channel purlins finish the roof while creating overhangs. Finally, seen here is the completed Esperanza system.
Due to the module connections, there was a concern about thermal bridging. A thermanalysis was used to test the effectiveness of the design. Although there is some thermal bridging, it is below the phase threshold standard and does not degrade the performance of the assembly.
Because of the modular construction of the units, variation of the arrangement of the boxes are made simple and affordable. Seen here are the base model units for the Esperanza system, ranging from 365 to 850 square feet. The estimated material cost for the 750 square foot base model is $77 per square foot for a total of $58,000. The plans of each unit are tailored to the residents of the Miracle Manor neighborhood in order to fulfill the lack of affordable housing in the area. In an effort to minimize embodied carbon emissions of the Esperanza system, most materials are sourced from within Arizona. The Ponderosa pine plywood is a material used for structural rigidity and has an added urgency of use. By preventing the wood from rotting, the system reduces emissions by sequestering carbon in the plywood rather than letting it rot in the forest or contributing to forest fire risk. The future vision for the project will include many customizable options for cladding materials such as scrap metal, thermally modified wood, and terracotta.
The mechanical HVAC system chosen to support the ADUs is a Chiltrix. Chiltrix heat pump, which conditions the building while providing domestic hot water. The heat pump is used in conjunction with the radiant floor system with two module types, a heating and cooling module and a thermal storage module. The radiant floor is achieved without the use of concrete, using phase change material, releasing and absorbing energy. A Santa Fe dehumidifier removes excess moisture from the air when needed. In order to maintain a healthier standard of living, the ADUs have an energy recovery ventilator, which provides a continuous stream of filtered fresh air. The proposed unit also features American assembled Energy Star rated appliances along with LED lighting.
In an attempt to create a circular economy life cycle of the Esperanza system, at the end of the building's useful life, the boxes can be taken apart, moved, recycled, or sold to other builders. Because the system is also manufactured entirely off-site and transferred to site to be assembled, there's a focused efficiency of material use and overall reduction from the beginning. The modularity of components also encourages expansion and contraction over time with opportunities for disassembly and reassembly off-site.
Most residential lots in Tucson allow for optimal east-west building orientation, but regardless of which way the front door faces, the design still meets the FIAS 2021 targets. A combination of natural ventilation, interior shades, and overhangs above each window reduce direct sunlight and solar gain in the warmer months. WUFI was used to test the inclusion of passive strategies and overall environmental impact. The HERS score of the ADU before PV is 35, and when taking into account the sunblock system, the HERS score falls well below 0.
Here in Tucson, water scarcity and flooding are projected to increase in severity with climate change. Too many impermeable surfaces are in our urban environment, create problematic runoff that does not get absorbed back into the aquifer. To limit this runoff, the Esperanza unit is raised over a water retention basin, which further eliminates the need for a concrete foundation. Water runoff from the roof is filtered through gabion planters and directed towards dry wells. This keeps water on site for as long as possible in order to replenish the aquifer and reduce flooding.
A photovoltaic array on site collects solar energy during the day. The array covers up to 1,000 square feet of area with 36 total panels. Since the ADU doesn't require that much energy to power, the sunblock system stores the surplus energy and shares it with both Teachers Row and the Avenue. Alternatively, electricity can also be exported back into the grid. Each Esperanza system ADU can produce a net surplus energy of over 25,000 kilowatts per year, which can help power the entire ADU itself, be shared as thermal energy via the sunblock system, or with the main residents on site.
Our goal with the Esperanza system is to provide energy efficient, affordable housing that fulfills the need for cost-effective living in an ever-growing community. Utilizing the modularity, affordability, and adaptability of the Esperanza system, our goal is to encourage the creation of self-sustaining neighborhoods across Tucson and the Southwest. Thank you so much for your time and consideration. This is the Esperanza system.
Great. We'll open up to questions from the jurors. 15 minutes for that.
Yeah, I'll start.
Yeah.
I'm really curious about the Chiltrix system. It's super cool, but is it, you need to convince me it's going to handle cooling in hot Arizona summers. So please do.
Honestly, we're not as familiar as we should be with the Chiltrix. It's a really complex system. From our studies and also knowing people in Arizona that use a Chiltrix system to heat and cool, it does prove very effective.
Okay.
While it isn't proven to be effective in colder climates, in our hot arid climate it is.
Okay, thank you.
I had, I think, 2 questions. First off, looking at your pricing estimates, I just wanted to make sure that I understood when you said it was what, somewhere around $55,000 for the construction of this ADU. Did you take a look into any sort of site or infrastructure improvements that might have to be made? When I've looked at ADU projects in the past, adding that additional infrastructure from the main house or from the road back to the ADU can cost almost as much as the overall construction costs. So, you know, I look at that 55 and I'm like, if we're talking just about the construction of the building, maybe. But if we're talking about overall, you know, land development, infrastructure build up, I think you might be a little low. So I'd love to hear your thoughts on that and what your explanation.
Yeah, so the pricing is actually just for the construction of the building. We did not actually look into the reconstruction of the site.
Yeah, no, that makes sense. And then I think the other piece, looking at that, I like radiant cooling, and I think you're in a climate for that, but I just want to make sure, did you think through any sort of user comfort issues or any sort of potential condensation issues? And did you do some sort of dew point analysis? I heard that you had a dehumidifier in there, but would love to hear more about, did you think through that whole operation and make sure you're not going to end up rotting out your plywood? Yeah.
I mean, there is always a concern with that there. So that's why we put the Santa Fe dehumidifier in. In terms of occupant comfort in there, it's expected. I'm sure there will be hot days that the Chiltrix will not be able to support the system, but for the most part.
Well, and I actually worry about most of the radiant cooling systems that I've seen are actually based on ceiling panels, because being in direct contact, I'm imagining, walking barefoot through a building where your floor is 60 degrees is going to be a comfort problem. It's more acceptable on the heating side because again, warm on your feet, not a big deal. But yeah, just curious about that. Okay.
I think you knocked it out of the park. There's so many really exciting things about this, coming up with it. We need affordable housing so badly. And so these ADUs are a vision for the future of how we can meet this great need across our entire country. I love the phase change flooring. I think that's pretty unique. The air to water heat pumps was a really great idea that I haven't seen before. And of course, the blue jean insulation is pretty cool. I think it's a really simple, elegant design of putting them together at an affordable price, and the flexibility of being able to move it is just really innovative and really a great idea. I think you might have gone overkill on the solar. You might have lowered your cost a little. I don't know what you can sell it back to the grid for or sell it to your neighbor for or something, but you might be able to lower the cost a lot by taking off some solar. I've never seen a HERS -99 before, so that's pretty spectacular.
I can just add a comment real quick. Yeah, I think we definitely did a lot of just development, just kind of thinking about, what the future holds for the Esperanza system and just kind of how, what's really nice is that, with all this, variation in arrangement, it's easy to kind of, do that same thing with the solar panels as well. And then kind of, change it up. Obviously, like also based on unit, it's very easy to change up. And I think that's where we also wanted to incorporate that for the variations. And I think there's a lot of possibilities for that too, just to change up.
Scaling.
Essentially. Yeah. So. Yeah.
One question I had was, you're gonna use like a land trust to provide a lower cost for the land. How do you do that with an existing home on the site?
We know that that would be a difficult endeavor to propose to an existing resident. However, many of these residents are being moved out of their homes because they can't afford them anymore. So we see the land trust as an opportunity for them to get supplemental income while having an additional structure on their site to provide even more supplemental income to them, provide generational housing for them as well. So that's one opportunity for that. We also partnered with Habitat for Humanity for their construction services, if they so please.
Do you put both houses in the land trust or just the ADU in their land trust?
I believe we just got the ADU for.
So you subdivide the lot? I don't know. Okay.
I'm not sure about that. Sorry.
We still got 10 minutes.
Yeah.
The camera. Oh, the camera for the jurors isn't on, so I can't tell if it's okay now.
Texting you that, Jack.
Okay.
Yeah.
Your camera's out for some reason.
So if I can go, it's okay. Yeah, I think just a logistics question. Some of the keys in the longer narrative we're not aligned. So could you just walk us through how you're doing air sealing and vapor barrier on this project and where that happens and what the product is?
Sure, yeah, that's a great question. So after the structural plywood modules are put together, a self-adherent hydro gap membrane wraps the building. And for the roof,
And
hey, go ahead.
and like how is it sealed underneath the building too?
Yeah, that's a great question too. So underneath the building is actually a double layer. So a vapor sensitive membrane is draped over the wood joist structure, and then the wall modules are then placed over top of that. And then the self-adherent is then, the membrane is then over that. So there's a double layer at the foundation condition.
So there's nothing underneath the plywood?
Well, the membrane is, yes.
Okay, the membrane is under the plywood, and then there's a double layer on top of the plywood.
Exactly, yeah.
Okay. Yeah, I think my biggest question for you is I think there's a lot going on. It's very exciting and innovative. I just wonder if it's too innovative in the retention water, like the retention pond underneath the building. I'd say like the number one thing that we think about for resilience is getting water away from the building and the foundation as much as possible. And then in this building, you've dug a hole under the building and are inviting water to come in. And then the building is made out of plywood. So that's another concern. There's a lot of potential for rot. Can you just walk me through why you think that's a good idea and what you would say to people who have concerns about potential moisture issues?
Yeah, so this was something that we've been worried about throughout the stages of the project. But the ways that we addressed what you're specifically talking about is that the wooden joists are coated in a material that will help to prevent it over time from rotting. And also the roof system and its overhangs direct the water into the gabion planters to the side of the site. So the water retention basin underneath the building is more of a backup for the gabion planters to the sides. So, and because it's Arizona, it's not raining all throughout the year. It's just very hard for certain months of the year. So this is just, it's not going to always have water underneath the building. It's only for certain times of the year, if that answers your question.
Sure.
So I'm sorry, I did want to commend you because you had all the control layers in the building envelope. You had drawings for it. I saw how the window is going to be integrated. I was really thrilled to see that. The one you said reuse for peel and stick, it's the business I'm in. Taking peel and stick off is always going to be a challenge. So if you want reuse, if that's a focal point, you might want to think of an alternative material.
Elizabeth, did you want to add something? No?
Elizabeth, would you like to see our model? I know it's off camera.
Sure.
Oh, and I love models, by the way. So thank you guys for bringing one. They're cool.
Yeah, that's right.
And while you're showing that, the only other question I had, you call this modular. And when I think of modular in the construction industry, I think about boxes built in a factory and then delivered on site. So to me, this is more of a kit of parts. So is the assembly on site or in a factory?
The assembly is on site, but the modules are constructed off site and then transported. And then
whoa.
Okay, that's good. Just put it back. Thank you.
Because it's a really cool kit of parts. The DIY could do it. I would, instead of saying modular, I would probably call it a kit of parts, just from the way you think about it in the industry.
Flat pack.
Yeah, exactly. Perfect. Yeah.
I do have one other question too. I think one of the concerns that owners have always had around ADUs are being able to have some privacy, but it does look like, at least with this design, all of your large windows and your outdoor public space is facing directly towards the existing home. Do you have any concerns about that or some ideas on how you'd address it?
Well, the reason for the windows on the north facade is because that's where we get most of the ambient light into our building. in order to reduce the need for having to have lights on throughout the day. And then we just provided curtains to add that privacy. That's what we used.
Great.
I can just add a comment as well. Every single orientation of the building fits the FIA standard. So that's just another customizable option if they want to change the orientation.
Are you going to be able to get this built?
We're hoping so.
And that was really cool about partnering with Habitat for Humanity as well, because we were able to kind of meet with them and, go over all this stuff, and they were very, excited for us and different things like that. And it was just kind of a cool experience to kind of get some feedback about next steps, if that's a possibility and different things. And I think that was what was really special about having them as a partner, is to get all this really good information, real world. And that way we can maybe, if we get that opportunity, we would have definitely a way to go with it. So that was very exciting, I thought.
I do have a question about the U-Block product. So thinking about building this, it seems like your biggest struggle is going to be getting a building official to accept that it's a valid system. Have you worked on thinking through that, or is U-Block, have they worked through getting approvals to be accepted under the IRC, or is this going to be engineers got to sign off on everything type of situation?
I mean, it's a new system for the United States. It's probably the first time a U-Build module has been in the States. So as of now, we kind of foresee just permitting officials coming to site to check off everything. And because everything is CNC, the quality control and joinery should be very precise. So
yeah, that's my only concern on this. And then I did have a question. I was looking at your window details, and you went through your kind of phasing of that. Walk me through getting windows in again. Love to just make sure we got that figured out.
Of course, yeah. So because it's DIY friendly, I think we thought the easiest way to do it was from the outside. So after you finish all the plywood structure, then the flange windows, just a little fin, is placed in from the outside.
Great. You have time for maybe one last comment or question from the jurors?
Thanks for your innovation and
Yeah,
really
really
thinking
cool
outside the
project.
box.
It's very cool.
Yeah.
Okay, great job, University of Arizona. Next up, I believe we have University of Tennessee, Chattanooga. If you're in the building, come on up.
Yeah.
Lots of Tennessee. What is this, Nathan?
Yeah.
Well, Tennessee is actually implementing some pretty, in some markets, strict, especially Nashville.
Yeah.
Energy codes.
Oh, great.
It is interesting that
Yeah, strict. Like,
Tennessee
you
has
have to use
a
CI on the exterior, mandated by code,
Oh,
which is, interesting. But yeah,
okay.
I've never seen any place
So we'll just,
that's not on any.
let's try to get
Tennessee's like not on any energy code. I mean, it's like
yeah. So it's like they have a state code, but it's pretty.
it's very
But you look at like Chattanooga.
exterior insulation. Sorry.
But like you look at Nashville, Metro Davidson County, Knoxville, Chattanooga, a few others, like they are taking like approach where it's like
I hate that little noise, like, when
I
people
want to
actually
do like I want to do better, looking for the surrounding municipalities to follow. Which is just a little interesting. I kind of look at
Elizabeth, can we do an audio check with you real
Davidson
fast?
County in Nashville, similar to
want
Denver,
to
where
y'all want to just
there's not going to be a lot of like large plant communities going on in there. It's gonna
Hello,
be in
my
the
name is
surrounding
Cade
municipalities,
Black.
and people
I
are
am
gonna
a
be
senior
driving
majoring in
into
chemical
Nashville for
engineering.
jobs. But it's
No, yeah.
Maybe I should slow that down.
Yeah.
Hello, can you hear me?
Yeah, it's okay, but if you could get just closer to the mic, that's super helpful.
Okay.
Yeah.
How's this? Is this any better?
It's a little better, yeah.
Okay.
I think like you're kind of to the side of the mic, but if you can be in front of the mic.
I'll probably still step up.
Just step up.
Yeah.
That'll make things easier for everybody.
Lauren, do you want to try to say a couple
Yeah.
things?
Yeah.
My name is Ashton West. I'm interior architecture major.
That's great.
Okay.
I don't know. I'm Mel. I'm also an interior architecture major.
Awesome.
And I'm Chelsea. I'm a construction management major.
Great, thank you.
We'll get started here in 5 minutes. If at any point you don't hear him, Elizabeth, feel free to interrupt. We can hear you loud and clear. So that way
Okay,
we'll get
sounds
them
good.
up a bit.
Thank you.
I'll just step up to this thing.
Yeah, just
slideshow to advance.
Yes, let's do that. That would be great.
There we
Yep.
go.
Looks good. Awesome.
Oh.
We'll wait till the exact start.
We're good.
Or trickling in from other rooms. They want to check y'all out.
Yeah, for sure. Sounds awesome. You guys doing awesome.
And we do have 5 minutes. Do you want to run out real quick and grab some water?
I should. Having more left, I think. Already.
The water, there's a drinking fountain right next to the rooms over there.
I was like, oh, this little clipper. How you doing, Dr. Lee?
He's as nervous as we are.
I know.
I'm not nervous.
This is fun.
Yes, this is awesome.
It's all fun.
That's right.
Y'all having fun planned while you're in Colorado?
We're gonna go visit Golden today.
Yeah, downtown.
Just look downtown one more, because we didn't really get to look much yesterday. Yeah.
Go to Woody's Pizza.
Woody's
Oh.
Pizza. Okay.
I did see that one online.
I love pizza and salad buffet.
Cool. We saw this burger.
Really
place.
good Bloody Marys, if that's your thing.
What was the name of that burger place?
Oh,
Atomic.
that's a good spot.
So-
Atomic is good.
I love burgers, so
Yeah.
I figured like I saw that sign, I was like, what is this?
Bob's is really good. They have In-N-Out also down the way. if you've never
I
been.
know, we don't
Yeah,
have
I
it in
haven't.
Tennessee.
Yeah, that's really good.
Local's better, not chain.
And one of the things I always recommend is go up to Red Rocks.
Red Rocks.
Today's Saturday, so there's probably a concert. They won't let you in the amphitheater.
But you can see it.
It's like a hiking, they have hiking trails. It's Red Rocks National Park and amphitheater. It's awesome.
Oh, cool.
But they do have yoga. Yeah,
Oh,
they
that's
do yoga
awesome.
on the racks in the morning.
I go
so
hiking
Saturday.
in Chattanooga.
It's a super cool venue. And
It looks out all over.
Yeah, when I've had friends come and visit, they always say like, that was my favorite.
Is it like natural, like a natural amphitheater?
Yes,
That's cool.
it's like carved out into the
That's
rock.
awesome.
That's really cool.
Super nice.
Yeah,
Like
we may have
they
some
probably
hours.
have a concert going on there tonight, so they'll usually like close off the amphitheater at like 3 or 4 because the concerts. I'm just assuming those are concerts.
Yeah.
Yeah, I think she was saying they do yoga on the rocks. on Sunday
I could use some yoga
Oh, I would
probably.
I need that right
Yeah,
now.
I could use some zen.
Again.
Yeah, that's right.
I just have to
That's
do-
right.
It's funny.
Y'all did the double.
The double.
That's
Yes.
right. You can't forget us. Yeah, that was
His
crazy.
face looked familiar. I remember.
Yeah.
It was like, yeah, oh man, that was my bad. They were like, they can play videos, but they can't play recorded.
That's
videos.
right, yeah.
I know, we're like,
It was good because we were ready to present it.
Yeah,
Right? So it was fine.
And hey, you made it this far.
That's
so
right.
yes,
I
it's
know.
something, right?
We were so happy to see that. I remember looking at seeing our logo on the screen. I was like, oh my goodness.
Yeah.
It's so crazy.
I know.
Great job.
So you think that whenever I speak, I should like step up like
Yep.
this?
Yeah. Just like step, pivot forward.
Sounds perfect.
You project well anyways.
Yeah, I have a really loud voice.
You have the deep voice compared to all
But I
of
think
us.
it's like she said, it's you gotta come at it from the front, not the side.
That's why mine was weird.
Yeah, we might like scoot down just a little bit. I'll step up like this.
Yeah, that's how the other groups seem to do it. They kind of all step back and then step forward.
Cool.
Or pass the mic around.
Yeah, it's gonna happen. We're gonna eliminate as many errors as we can today.
That's all right. Have fun.
I'm glad to see a national native from the same area.
Yep, that's awesome. Oh, Nashville, Tennessee, yeah.
do you ever work with the Dew plant in Chattanooga? Or Hickson, I guess?
I'm not there, but I've been to we have one in Memphis.
Okay, cool. Awesome.
My mom lives in
a little town called Copper Hill, Tennessee.
Yeah.
Oh,
You
I know.
cannot know where that is. It's
I'm,
like
from,
this-
I'm from a really small town too. so
Oh,
of
you
course,
are?
Yeah,
Okay.
yeah.
So I go there quite, and I'm
Yeah.
from North Carolina, so I used to go there quite a bit.
Yeah, the town that I grew up in probably had like 700 people in it, like one red light. So.
Okay, well, that's a little smaller
One of
than,
those.
I think even Copper Hill.
Yeah, and I'd never been on a plane before I traveled out here. So like, whenever
Really?
Yes. So when I got on the plane, like I was just like, this is surreal.
So he's gonna lead us back. So
Yeah, they're trying to
Perfect.
test my skills
Yeah.
in Atlanta airport.
That'll be a good exercise.
Yeah.
Where you'll know that you can do it on your own.
Yeah, for sure.
Okay, Elizabeth, I see that you're with us. Again, if you have issues with the audio, feel free to just chime in and let them know to speak up, and they'll hear you loud and clear. With that said, we will introduce the University of Tennessee Chattanooga with the Mock House. Take it away.
Hello, we are the Chattanooga Mocks from the University of Tennessee at Chattanooga, and today we're going to show you Mock House. Mock House is a single-family net zero home that is flexible to changes in home versus work life and can evolve with the ever-changing climate, ultimately emphasizing functional design while addressing the local design guidelines of the St. Elmo Historic District.
Mock House was designed to appeal to the expanding Chattanooga population of young professionals. The area has seen an influx of people from larger urban areas because of its booming startup scene and lower cost of living. Since the pandemic has had such a large impact on how we use our homes, we have incorporated amenities for those working from home with 2 possible office spaces and an air-sealed building envelope to reduce outside noise. Our design also features a spa-like master bath, open floor plan, large kitchen island, and 2 living spaces to appeal to the modern buyer.
Our lot is located in St. Elmo Historic District of Chattanooga, Tennessee, in a 100-year flood zone with a Category 4A mixed humid climate. Next slide.
A C-shaped building mass was chosen because of the long, narrow shape of the lot, the site's orientation to the sun, the passive design elements we wanted to incorporate, and the historic zoning guidelines set forth by the St. Elmo Historic District. The St. Elmo Historic District requires new homes to be variations of rectangular and square forms. Along with the historic zoning guidelines, we also reference the IRC 2012, the ECC 2009, and the City of Chattanooga codes for plumbing, electrical, mechanical, and gas. Next slide. You'll see that the front of the lot faces due south. The orientation maximizes energy savings through passive design on the narrow lot because the C shape utilizes 2 ridge lines that run east to west, which orient the building towards the sun. By increasing the length of south-facing walls and incorporating several windows, solar gains are maximized in the winter when the sun is lower in the southern sky. With fewer windows facing the north, heat gain in the summer is minimized. Next slide. So this slide shows how the homeowners have ample access to nature because the home wraps around 3 sides of the patio, allowing for a direct connection between the interior and exterior. The shape also allows for more natural light to filter in, which reduces the need to turn on lights, reducing energy consumption. In summer months, the windows on the east and the west can be opened to allow the natural breeze to cool interior spaces. And windows with insulated glazing are used on the west to minimize the impacts of prevailing winds in the winter. The next slide also shows how the floor plan maximizes passive energy.
Mock House has a total area of 2,363 square feet, split into 2 levels with 4 bedrooms and 2.5 baths. The floor plan was separated between public and private spaces. The interior includes insulated interior walls, bamboo flooring, low VOC paint, recycled glass backsplash tile, LED luminaires with smart light device dimmers and receptacles, as well as 2 storage closets, pull-out storage doors built into the last 4 steps of our staircase that leads to our 2nd level, where there is access to a walk-in attic space. Automatic roller shades are applied to our casement windows that are controlled by heat sensors to improve comfort and implement passive design strategies of natural lighting and ventilation. Next slide, we'll see our interior view. This interior axonometric view illustrates the public space of the home. It was designed to create that entertainment and social gathering environment. It also provides the user the opportunity to have that indoor-outdoor experience created by the large sliding glass partition that leads to your outdoor living space. Next slide, we'll see our 2nd level. This space was provided for the professional couple who want to make this their forever home and plan to start a family in the near future. It's equipped with 2 bedrooms, a full bath, an office space, and a secondary living space. Next, Chelsea will talk about our envelope.
For the construction of mock house, we chose readily available materials to cut down on lead times and transportation costs. The exterior walls are 2x6 wood studs infilled with mineral wool batt insulation, which was chosen for its higher R value and great sound absorbency. The home is then cladded with OSB and 2 inches of polyiso for exterior insulation, followed by a drainage cavity to help combat any moisture that makes its way past the hardy board siding. The entire envelope is air sealed. All penetrations are to be sealed with foam or caulk, exterior insulation taped, and continuous sealant used at transition of materials. The home is built above grade for 2 reasons. First, the St. Elmo historic guidelines call for the home to have an exposed foundation, and if there's any extreme flooding, there is less of a chance of interior damage.
For the HVAC system in mock house, we went with a VRF and an ERV. We chose the VRF as it is a ductless system and it can actually serve multiple zones throughout the home, each with different heating and cooling needs. To combat the humidity of the area, we chose an ERV. This is actually able to remove most of the moisture that is present in the air before it enters the home, where it could then further damage into the interior materials. For the appliances used in mock house, they are all Energy Star certified. We're also utilizing water sense technologies throughout the home as well.
The Chattanooga area receives an average of 51 inches of rainfall per year compared to the national average of 30 inches. This, along with the home being in a 100-year floodplain, required us to use various water control tactics. For our landscape, we have selected plants that are native to Tennessee and have great water absorption properties. The home has an gray water system to irrigate landscape beds and grass areas, as well as rain barrels for watering the garden.
Mock house's advanced building systems and well-insulated building envelope results in us being significantly beneath the state average for annual energy consumption at approximately 11,635 kilowatt hours per year. Despite the St. Elmo historic guideline that just allows us from having solar panels facing the road and the fact that our home is south facing, we're still able to design an efficient 13 kilowatt system that consists of 32 PV modules, 32 microinverters, and an efficient battery cabinet that will house a portion of our solar energy. This yields a total solar generation of 24,746 kilowatt hours per year. Our HERS score was also significantly affected from the result of our building system, as we were able to reduce this without PV to 48. With PV, we were able to knock this down to -55. We're also able to calculate the site and source EUI respectively at 16.8 and 19.83 kilobtu per feet squared per year.
The St. Elmo region of Chattanooga has boomed over the last decade. This historical area is home to just under 3,000 residents who are renovating historical homes or residing in new builds. The mock house with renewable energy cost about $305 per square foot to build, compared to a home without renewable energy could be built at about $285 per square foot. Next slide. The house with renewable energy cost approximately $47,000 more for construction, but the occupant would see a return on investment in less than 9 years. This home generates enough energy to sell back to the grid and will see long-term benefits in energy and water savings.
With respect to CO2 emissions, we're able to decrease this beneath the national average at approximately 6.3 tons per year. We're also sending a portion of our solar energy back to the grid, which ultimately results in 4.7 tons of CO2 saved per year that would otherwise be emitted by electricity companies. My name is Cade.
I'm Ashton.
I'm Mel.
And I'm Chelsea.
And this is Mock House. Thank you guys so much.
Okay, great job, University of Tennessee, Chattanooga. We will open it up for questions from the jurors. We have 15 minutes. Elizabeth, you want to start us off?
Sure. I think this is a really beautiful home. I love that you went with the historic district. I think that's a really great challenge to do also something that's historic and going for net zero. I wanted to give you a chance. I didn't see the embodied carbon. I think there's just like a different interpretation of what embodied carbon assessment is. So if you could walk us through kind of what embodied carbon assessment means to you and how you took a look at that, that would be super helpful for me.
Yeah, so in order to ultimately reduce those CO2 emissions, we first took into account the appliances that we were using. So I know that equipment such as your dryer can actually emit a portion of your CO2. So in doing that, we went and spec'd out some appliances that were Energy Star certified in order to ultimately decrease that amount. And on top of that, we realized that we are gaining a significant amount of solar energy per year. And so we ultimately decided to send that back to the grid. And per EPA, 0.85 pounds of CO2 are emitted per kilowatt hour generated at those electricity companies. So in doing some calculations and determining that we were going to send roughly 44% of our solar energy back to the grid, it saves the 4.7 tons of CO2 a year that I mentioned in the slides.
Okay, so figure 17, where you're looking at CO2 emission comparison, that's looking at kind of the solar
Yes.
generation versus the energy use of the home.
Are you talking about the pie chart?
Yeah.
Oh, okay. So the pie chart actually shows the amount of CO2 that we are emitting per year. And then the other portion is the amount that we are saving by sending our energy back to the grid.
Okay.
Just kind of wanted to get a visual representation.
Okay. Yeah, because typically embodied environmental impact is the actual how much energy it takes to produce the materials in the home.
So I can
yeah.
actually elaborate that a little bit on that. So as we were choosing some of the interior finishes for the home, we took a look at, a lot of the spec sheets, because one of the most important things for this project was to make sure that the indoor air quality was really great for the homeowners, since they're going to be working from home. If they have kids, maybe they'll homeschool them, maybe, something with the pandemic might happen again and everyone will have to work from home. So making sure that, the materials were really good for indoor air quality was important. But as we were looking at those specs, we also took a look at, how those materials were manufactured. Are they local? We tried to keep materials within that 500-mile radius of St. Malo and Chattanooga. So things like that for the interior materials.
Thank you.
Yes, I have a question on the solar. You got to a Hertz rating of -55. I don't know how you got 103 Hertz points off of 13 kilowatts of solar.
Yeah, so we have those solar panels, the 32 PV modules that are 400 watts each, fixated in 3 different directions on the roof. So we have some on the
they're
east.
not even south facing.
Yeah, so that was one of the challenges of the projects that we were facing. So we actually were able to go into software and put the house into it, and actually put in there that it's not, the solar panels weren't south facing, that they're on the north and the east and west side. And at the with the angle that we had them on the 612 for the roof, that is the amount that it was giving us for the calculations.
So wouldn't you rather lower your cost of your house rather than go so deeply negative?
Yeah, of course. We were wanting to test the ground to see how net zero we can actually make the home. And with the specifications that we put into the system, Chelsea actually did the cost analysis like she put to see how much it would be feasible. But for future purposes, it would be interesting, as we are so deep at -55, to maybe we don't need 32 PV modules. Maybe we only need like 25 or something like that, or even significantly less. So it definitely will be interesting to see how that would ultimately affect the cost. But that is a great point to take that into account for sure.
Or what does your utility buy your electricity back at, that this is a favorable situation?
I know that EPD buys it back, but I'm not sure what the cost that they buy it back at.
Yes, I don't know off the top of my head either.
It changes.
Are they part of the TVA system?
Yeah.
Okay.
Yeah.
It gets weird. Yeah, just to let you know. Yeah, TVA typically, at least based on some experiences about 4 years ago, they are very selective about what they will and won't buy back, and how much they will buy back. And you typically, to get a full, or at least close to a retail rate, at least how it used to be, was solar providers were putting in applications January 1st to get a rebate to actually make it worthwhile. So yeah, I'd just be careful and assuming that much PV and trying to offset that much. I'd say keep it closer to the consumption of the home, so that you're maybe slightly overproducing, but not so much overproducing.
Okay, makes complete sense. Yes.
Yeah.
There's 120% rule. Most people go by, like if you want to add an EV or something.
Okay.
Awesome. Just looking at the design of the home, I love the idea of having live workspace, being able to do that. But I'd look at two things that I was wondering about. Parking for the home. How is that being handled? Is it on-street parking? What's going on there?
It is on-street parking.
Okay.
With it being in a historic zone,
Yeah.
there are regulations for parking and where you can and cannot have a driveway or have a secondary structure like a garage.
Oh, okay. Okay.
So, and with the block being so narrow, it doesn't leave us enough room with the setbacks on either side to
Okay.
have that driveway to put the garage in the back. So it is street parking, which is typical for the area.
There is options. There is a house located diagonal from the back. There are houses in the area that will connect driveways, and that is an option if we wanted to communicate with that homeowner.
Okay. The other question I had, walk me through how you're going to insulate your crawl space. I was looking at the detail. I had a couple questions about it. Yeah. And I think you had a section in there. So if
Yeah.
you could pull that up, I think that'd help. There you go. Yep.
Okay, so for the installation of the crawl space, we have a vapor barrier at grade, the polyiso oil face along the poured concrete walls, and then that insulation between the floor joists.
Okay.
Insulation of the whole.
I'd just say, let's think about your thermal envelope, think about where you're going to get heat exchange between the home and the outside. Right now, you've got a double insulation type of situation where you're insulating the wall of the crawl space and the ceiling of the crawl space. From what it looks like, you're trying to create a conditioned crawl space. So you have insulation at that floor joist that you just don't need.
Okay.
So yeah, something to look at. Yeah, I think
sealed.
Yep. And then just wanted to talk, I was reading through your narrative and wanted to understand some of your market analysis, price comparison. Where do you really think that this home at, with solar somewhere around $700,000, it's
So-
pricey, where do you think you're going to be and what's that going to look
So
like?
that really is a pretty true cost analysis for the home. The one thing that is not included in that price is the price of the lot. The lot we chose was not for sale. The average price in that area is about $30,000 to $50,000.
Okay.
But our pricing does include the GC's overhead and all of those line items that really get encapsulated into that construction cost to build. And we did do some comparisons to homes that were being sold in the area. And one that was about 100, renovated house that was about 100 square feet more than ours was selling for $725.
Okay.
So
Wow.
it's not an unreasonable amount. Prices in Chattanooga.
That's all
are crazy.
relative.
I know.
Yeah.
Yeah,
That's all relative.
If I was
I'm not
in
living
Milwaukee 10
there.
years ago, I would have fainted, but like
Yeah.
nowadays, it's literally,
Yeah,
that's what
for
people are
sure.
paying, and
Great.
price per square foot is really selling, it's really selling for that much in Chattanooga.
Especially for the amenities. It's got a greenway, local grocery store, walking distance from several downtown area.
Hiking
People that are-
nearby.
But can really two young professionals afford that?
Apparently.
So our target market is young professionals moving to Chattanooga from larger cities.
From California.
Yeah,
Yeah.
who have like a
New York
much
City.
higher cost
They're not
of
being
living.
used to paying those higher costs
Yeah.
over there.
A very high influx of people.
Which
from
we
California.
have been seeing.
Yeah.
There was a study that we looked at by, I think it was United Van Lines, that shows, the migration patterns between people, especially during the pandemic. And those two Tennessee were mostly from California, Texas.
I'm from Atlanta, the Atlanta area.
And
then
Colorado like Nathan.
Yeah.
Yeah. I will say I really appreciate the historic aspect and really trying to integrate into a neighborhood. At least what we see going on in the Denver area right now is a lot of scrape and rebuild and not really trying to be true to that traditional aesthetic.
That was one of the things that
So-
we thought was really important as
Mhm.
well, because a lot of the new net zero homes, we felt like, you do see these new modern builds and they're really cool, but that's not everybody's style. And especially in Chattanooga,
Yep.
people do tend to look at the historic homes more and just kind of that older style as well.
Yeah. And they do have that kind of stereotype for,
Yeah.
energy savings homes, that they're modern and cold, and we're trying to prove that, no,
You can
they can be
still
warm and
adhere to the
inviting,
old
just like you
style
like.
homes.
Yeah.
Yeah, I love it. I want it. That's the house I want. I want this house, not for $720,000. I want this house.
We may cut you a deal.
The one thing I do commend you because you guys were thinking about the control layers and the building envelope. The only thing I didn't, you had some of the water and air management on the back of the window. I would have liked to see the window flashing. You have to, that integration on the front is so important. And so if you just drawn a line that said window flashing, I would have been just spot on. I think that's it. Any other? He asked my price point versus the market because I was pretty blown away.
Yes.
Yeah.
The house we looked at was just down next road.
Yeah,
Next street
it's
over.
really close in proximity.
I keep telling myself I've done something wrong in my career.
Like the price of housing in Chattanooga has
crazy.
exploded over, like since the beginning of the pandemic.
I want to be in real estate.
Yeah,
Yeah.
great.
We have 3 more minutes if we have any comments or questions from the jurors.
Oh, I think the only other thing I was gonna say, so I love the design, but you have some pretty expensive components. We already talked about PV, the polyiso versus a polystyrene. You lose a little R value, but it's a lot cheaper per square foot. So as you think through to bring that price point down so I can buy it, there are trade-offs, and certainly performance and body carbon like this. It's a complicated equation.
Yeah.
Appreciate the design, but just as you did a couple of more iterations, you might come to a place where it was a little bit more affordable.
Okay.
And the square footage. I think you could bring down the square footage and more, absolutely bring down the price. The little bathroom on the main floor is, needs to be redesigned, I think. The powder bath, you could have done something better on that.
Yeah, and I do think the only other design comment I had, looking at the floor plan, you have that nice large back deck, but it seems like the only access to it is through the master bedroom. So trying to find either connecting it through the outside or trying to find an interior passage that you can really make that connection to outdoor living space would be great.
Sure, yeah. Great. Yeah, I think that about wraps it up. Let's have a round of applause for
Yeah.
Thank you guys so much. Okay, I believe next up we have University of Wisconsin, Madison, and Milwaukee here in the building.
What time are they starting?
Oh, they got quite a bit of time. 1:30.
I am one to
We got 15 minutes. No, they
So we have a 11:30 to 12 and then lunch.
Well, how do you think it's gone so far?
Seems to be going pretty smoothly, I would say, but yeah. I think it's important to hear what y'all think. I think maybe we had a little hiccup there at the beginning. Trying to get Elizabeth to hear everyone properly, but.
Oh, no.
Recovered.
Yeah.
Yeah, I'm just wondering how much of a stickler to the design competition rules versus the what we've seen and making good comparisons among those.
Yeah,
Because
that's
there's
always
some where I'm like, oh, that's a really good project, but you missed this and this.
Yeah.
So I'm like, I don't want to. Well, we'll talk about it more later. Yeah.
Yeah.
Yes. Well, I can pause it for a sec. And we will kick y'all off in just a couple minutes. I know this anticipation is probably killing you. Y'all have any fun plans while you're in Golden?
Can I go hiking at Red Rock?
See, that's what I was just
Yeah.
recommending. You gotta go to Red Rocks. But they might not let you in to the amphitheater. It's Saturday. They probably have.
Okay, we gotta look and see if there is one or
Yeah,
not.
she's gonna look it up for you.
But I would say what you typically go before 4.
If you get there before 4, yeah, I don't know
Yeah.
if that's gonna be possible today, but
Yeah, maybe tomorrow.
Yeah.
Yeah.
Definitely go to Red Rocks. Anything else?
We went to Royal Arches yesterday.
What is it?
Royal Arches.
Royal Arch.
We went to St. Mary's Glacier.
That's a good little trail. I
Where?
like that one.
Yeah.
I don't know Royal Arch.
She said glacier?
It's in Boulder.
It's in Boulder.
Yeah.
Oh, no. Go to Woody's Pizza before you. It's then downtown Golden. They have pizza on South of Page. Do they have an event today?
I don't know. I wonder if it's still a little cold
Yes.
at night. for them.
Lotus is playing today if you're into that. Sublime is next week though. Yeah. Ludacris and Nelly next week too.
Tonight?
No, next Dom Dalla on Sunday. I don't know who that is, but I'm sure y'all might.
No.
Okay, we'll count y'all down for the last couple minutes. Do you want to get the doors and we'll get started here in a sec? Sorry. Okay, this is your timer here. Keep an eye on it. You'll have 8 minutes and then 15 minutes for Q&A. So with no further ado, this is University of Wisconsin-Madison, University of Wisconsin-Milwaukee with the Egg Harbor residents. Take it away.
Hello, everyone. Thank you for your time today. We are delighted to present our project this afternoon. My name is Gabrielle. I'm an architecture student at the University of Wisconsin-Milwaukee, accompanied by my peer, Tim, as well as our teammates from the University of Wisconsin-Madison, Sammy, Evan, and Kirk. Our clients are moving and starting their own family. They have always enjoyed the community, outdoor amenities, and lifestyle in and around Egg Harbor. While we are designing a single-family home for this client, the city of Milwaukee is also our client in regards to this design's ability to be mass-produced in order to solve the Milwaukee city's affordable housing crisis.
So for our net zero strategies, we utilize 5 main passive design solutions, spec all environmentally friendly materials, utilize natural resource collection and factory production to reduce home costs productions.
The home is oriented to allow the max amount of sunlight along the long axis, allowing varying roof slopes with PV panels to capture the sun's energy all year long. Other systems in our design include insulation made from recycled materials, factory fabrication, rainwater collection, gray water system, as well as a slab on grade foundation.
So our floor plan is oriented with open public space all on the first floor to utilize the sun's light all throughout the day, and then a efficient double loaded corridor on the second floor for reduced square footage. We also utilized smart home system to control all of our passive design solutions for increased efficiency. We utilized modularity with regard to our factory production to give our clients a multitude of choices, which allows them to have a deeper connection to the house that they choose to build. And our class built a catalog of design styles that will serve for Milwaukee to be built with factory production in neighborhoods such as Josie Heights, which currently is an empty neighborhood. But with Milwaukee's $1 million, they hope to start factory production to build sustainable housing at an affordable price for inner city youth.
Diving into our energy systems, we will be using 21 photovoltaic panels mounted on the south-facing roof at a pitch of 9/12. From SAM, we expect this to produce around 10,088 kilowatt hours per year, and we also expect to see a payback period of about 14.3 years.
So looking at our energy analysis, we found that using REM rate, our house was consuming 34.1 million BTU per year. It's about 10,000 kilowatt hours, and we are producing 34.2 million BTU from our solar panels. We got a Hertz score of 27 without solar and -11 with solar. This is a big improvement from our semifinal, where we had a Hertz score of 43 without solar and 3 with solar. We see that our housing is mostly going to have a heating load as the majority of the load, mostly because our Wisconsin winters are very harsh and cold, followed by our lights and appliances, and then our water heating. We expect a minimal cooling load due to our climate in Egg Harbor, as well as our natural ventilation. So our goal is to create an airtight envelope and lower our infiltration in the house. We did that primarily through the walls and windows. Our windows have a U value of 0.2 with a solar heat gain coefficient on the south facing windows of 0.45 to allow for more heat to come in through the winter. And then for 0.25 for the non-south facing windows. All of those windows also have a low E coating. Our walls are R29 and they are double stud construction with blown cellulose insulation.
So for our mechanical systems, we use a 12 HSPF 22 or Mitsubishi electric air source heat pump. You can see it's shown here in the attic. This is a major improvement from our semifinal submission where we're using gas furnace. On the right is the condenser unit for this system, which will be which is shown here in the garage in green. We're keeping that in the garage to take advantage of the more mild ambient temperature throughout the year. So we won't need to use electric heating backup for that system. We're also using an energy recovery ventilator shown here in orange to help with ventilation and help with our heating load throughout the year. Our supply ducts or our supply diffusers are shown in blue and are turned in magenta. Here are some of the components of our plumbing system. So we're using PEX piping and multi-port tees to decrease the amount of piping used within our home. Shown here is a Rheem electric tank water heater and 14-port manifold that we're using to help provide immediate hot water to the appliances and faucets within the home. Here's a second level plumbing plan. You can see here in the closet, we have the washer and dryer, water heater, and manifold, and then the piping running to the bathrooms and other appliances. On the main level, we use the chase wall shown here in the kitchen to decrease the amount of piping and also prevent having piping within the exterior walls of the home because we have a cold climate and want to prevent freezing. Our cold water plan essentially mirrors the hot water plan, as you can see here. For our black and gray water plans, black water is shown in yellow and gray water in magenta or pink. You can see they go down to the main floor right here and then leave the house on the main floor right there.
So overall, we wanted to make our home as affordable as possible. Using RS means, we got a total home cost of around $296,000. Comparing that to a regular home in Door County, based on square footage, we're about $60 cheaper per square foot. Taking a look at the pie chart from RS means, most of our construction cost comes from the interiors of the home.
So factory production allows us savings through faster time to market, better quality control thanks to being in a controlled environment, and producing jobs for inner city youth. And the quality control allows us to have reduced material waste and a higher quality product for a lower cost.
For our embodied environmental impact, our carbon footprint reduction, you heard about a house being factory built, so that reduces material waste. We're also using local suppliers for lumber and concrete, which helps with transportation emissions. Then we're also incorporating a gray water laundry landscape system, which you'll see in the next slide.
So we'll be using both gray water and rainwater systems. Our laundry to landscape water system will use water from the washer, and that will irrigate the yard. Similar, as you can see at the figure on the bottom right, we'll be using gutters and downspouts to carry the rainwater into plant and soil beds. And in Wisconsin, compared to the total water usage, about 30% of that is outdoor water. So with these two systems, we have the capability to save about 74,000 gallons of water per year.
Here are the results from our Tally life cycle assessment. So our house is about 256,000 kilograms of equivalent CO2 over its lifetime of 60 years, which is about 4,700 kilograms per year versus 6,800 for the average US home. By square foot, that's 159 for our home versus 180 for the average US home. We're doing pretty well in that regard. Our improvements from our semifinal submission were our thermal moisture protection. Those are more proportional in non-renewable energy and carbon footprint in relation to their mass. You can see here our wood and plastics have a little bit higher carbon footprint in relation to their mass percentage, but we're decreasing this by using local materials like red oak that are abundant in Wisconsin.
So 1 in 3 Milwaukee renters pay more than half of their income, and the rate of minority home ownership is one of the lowest in the nation. So working with Milwaukee, we hope to create affordable housing and good quality jobs for inner city youth. Thank you all for having us come here today. It's been a life-changing experience. So thank you very much.
Okay, thank you, Team University of Wisconsin, Milwaukee, and Madison. We will open it up now to questions from the jurors and start off with you, Sue.
I just wanted to comment about that. I love your modular design and the flow of the house and everything, and that you didn't overdo the solar, you didn't overdo the mechanical. I have one question about that you mentioned about you changed the design to go from a gas furnace to a heat pump. We want the whole world to get that aha moment. What changed it for you, and what did you learn from that?
So obviously gas furnaces are using fossil fuels, and that's one polluter, and we're running out of that supply. So that's a more typical thing in Wisconsin, just because it's more standard practice. But we wanted to move towards that air source heat pump to have it be able to run off our solar panels and then be more like energy efficient that way. Yeah.
So what made you make that change?
Well, we really wanted to get off of fossil fuels.
Oh,
Yeah.
but why did you have it in your original design?
We were working with kind of standard practices of Wisconsin. So at the time we were saying, okay, we were looking at these houses in our community and most houses had a furnace in there. And then we realized that bad choice. So
we also, we were having trouble getting our HER score down without using a gas furnace for some reason. And we worked with some people that helped us with rem rate and figured out a way to use an air source heat pump that will make that work. So.
Okay, a few questions for me. Tell me more about your mechanical system. Where's your ductwork going? And if you could go back to that diagram, it looks like you've got your equipment in the attic, but I couldn't tell. Is this a conditioned attic or is it unconditioned attic, or what's the plan there?
It is a conditioned attic.
Okay.
We don't have a basement in the Egg Harbor home because the bedrock is too near the surface. Ideally, we would put it in the basement. So with the Milwaukee, with moving the house, like the designs and creating the Milwaukee too, we would be able to have a basement. And that would also be a conditioned basement. And that would help us with the efficiency of the system and also for maintenance costs too. Maybe it'd be easier for people to come and get in the basement for that. The ductwork we don't have in there, as you can see. I was talking to one of our industry partners about the HVAC ductwork, and he said most of the time for the buildings that he designs, he puts the he doesn't design the ductwork off the bat because he waits for the electric system and the plumbing system to be put in and then designs the ductwork around that. So
interesting. Okay. And the other question, I think also, do you talk with the manufacturer at all? Would they approve keeping that condenser in the garage? And what do you think that's going to be for occupant experience too? They're getting quieter, but they're loud, noisy, and move a lot of air.
Yeah. So again, that was also through talking to the industry partner about that. He recommended putting in the garage. He said that's the trend happening nowadays with homes.
Okay.
As for noise, we don't have a way of like mitigating that yet. We didn't think about that quite a bit, but having the garage is good for the cold climate. So we don't have to have extra heating backup for the condenser and system.
Okay. And then the last question about mechanical equipment, your laundry room, how big is that?
Do you know? I think it's more than 5.
Yeah, I believe it was 6 by 8.
Okay. Just looking at the heat pump water heater that you've chosen, they've got some pretty specific venting requirements or space requirements. And looking at that current setup, I'd be a little concerned about turning that small laundry room into a pretty uncomfortable space to be in. So just think about that and think about how that's going to impact overall occupant experience. But otherwise, I really like the design, really like your analysis in Revit on different daylighting and solar production ideas.
A lot of good things in this house. I love that you used offsite because I think that that's a growing trend. We just don't have enough labor to continue to build on site. So appreciate you guys, that consideration being included. I'm just going to highlight what I've been telling other teams. The integration of penetrations and walls is so critical. And in the submission, you said use caulk to put windows in, which is a bad idea just in general because caulk over time it doesn't last. So just a proper flashing scenario included in the submission. You did talk about the layers. Well, I was really excited about that. You talked about air and water management, but I just really want to see in these submissions how they all are integrated together.
Did you have any comments or questions for the team, Elizabeth?
Yeah, I would love to hear more about your wall system that you chose and which parts of it get manufactured on site versus in the factory. I think that's a really important distinction and an option for factories to think about, like which parts are made on site versus in the factory. I see that your second floor truss comes all the way into the exterior wall. And so I'd have you consider, like, do you really need that? Because that's a big thermal break that you could eliminate if you had the interior wall be load bearing. And then you wouldn't need that to be, you wouldn't need that exterior wall to be built in the factory. That could be built on site. So yeah, I'd just love to hear more about what you're thinking, what pieces get built in the factory and what pieces get built on site.
Yeah, thank you for your input. For the factory production, it's all oriented on 14-foot modules. So it would be like almost entirely built in factory and then shipped to site on tractor trailers that can carry it in around 3 to 4 pieces.
Is cladding done in factory? Like how finished is it from the factory? I think that's what she's trying to figure the question. Yeah.
Yeah. So yeah, the cladding and everything would be finished, and then on site it would basically just be from the interior, and not necessarily would be finished, and that would be done on site, and then it would be screwed together on site.
Okay.
And then how do you make sure that air and vapor barrier is continuous when you're putting everything together on site?
Really good question.
Actually, hi, I'm virtual and I don't know if anyone can hear me.
Yes.
All right, sorry. So I'm Clarissa Hollenkamp. I'm also an engineer from Madison. So that was a little bit some of my duty. So some of the things that you'd have to do with like the blown cellulose insulation is that's more of an on-site thing, is ensuring that you get at least the higher grade of that blown in there, and including that exterior layer around the house before you include your sidings and your different features along those things. And then when you're ensuring that when you're screwing it together, that you're sealing those breaks between and you're not allowing that leakage in.
Just a general comment on that. It's hard to do when you have the cladding on. That's the most, if I see cladding installed, typically it's on modules that are all enclosed. There are modules that they connect together. We just have to really think through what that connection system that has cladding on it. If you put the cladding on site, the integration is easy from a continuous air and water management perspective.
Yeah, and we also often see the exterior continuous insulation happen on site too, just because it's easier to get everything continuous between the different modules. So just something to think about.
Thank you for that question, Elizabeth. We still have about 5 minutes if we have any other comments or questions from the jurors.
Just a question from, is this going to be constructed? Did you I know sometimes the submissions are for a client, but I'm not actually sure if there's an actual client or is there a.
Yeah, we've been working with an actual client in Egg Harbor that wants to build it. So they're going to be looking into the cost of building it and like getting all the permits and stuff in the next couple of years. And then with Milwaukee, we're also sending it to Milwaukee because they're looking for design catalogs and stuff for their factory production that they're trying to start up.
And was this a class or is this a special project? How was the team formed?
Yes, so for our Milwaukee class, everyone designed their own house to be submitted to Josie Heights because it's going to be a community of different design houses. So you can kind of choose and pick which kind of style house you would like, but along with the Egg Harbor house. So the class collectively worked on the Egg Harbor house, and then each individual student is designing their own house and own set of CD drawings that will go out to bid at the end of the semester so that the city of Milwaukee can use those up to go into production, but they do not have engineering. So it'll be a complete set of construction drawings with a number put to it minus the engineering at the end of the semester.
And then the Madison side, so Milwaukee has a School of Architecture and Madison has a School of Engineering. So we are all in our senior design capstone. So we've been working on this since September.
Okay.
I do have a few other questions. Looking at your report, it seemed like the utility is allowing net metering, but buying back at a pretty miserable rate compared to the retail rate. Have you thought through self-consumption and how you're going to ensure that you're not just exporting a lot of energy to the grid and not getting full credit for it?
Yeah, so in Wisconsin, the net metering is about, you sell it back for about half of what you buy it. So what we tried to do was we didn't try to oversize it too much because then we'd just be selling back all this energy that would likely not be very beneficial, especially if we have to make a bigger solar size that would increase the upfront cost. We tried to size it basically we wouldn't have to sell enough, or we wouldn't have to sell energy back really, because currently it's not very beneficial.
And then the other question, you talk about your HERS score and modeling, and one of the comments in your report is that you started off with a without solar power influence, you got a HERS score of 38, but with solar power influence, without the PV system, it got down to 27. Can you explain what pieces you were looking at and what you changed to get it from 28 or 38 to 27?
Yeah, so I believe we may have mistyped in that report then, because those are probably just an intermediary number that we had come up with. So yeah, we assumed the house without any solar would just the envelope and everything would just be that 27. So yeah, I apologize for that mistake.
Oh,
in my
no,
report.
no, it's okay. We'll say at least so in Colorado, we're climate zone 5B for the most part, so not quite as cold as Minnesota, but sorry, Wisconsin. Apologies. We find it pretty difficult to get below about 45 without using some pretty intensive and expensive pieces of equipment. You know, for the most part, a similar home that is probably going to be built here, similar double wall system, similar air source heat pump, similar heat pump water heater, and maybe not as good windows as you all. We're going to struggle to get about 45 to 48. So I am a little curious about your model and how you got so low an initial HERS score without PV. We kind of see the scale as you get to warmer climates, it is easier to get a little lower. And then in colder climates, we're just stuck with a lot of heating energy. So no, I'm just curious is all.
And building off of that is it looks like there's no cooling load.
Which, yeah, and that's a
Which-
fault of the HERS modeling software. I'll admit it is nowhere near perfect.
We got in the low 40s, but we had used steel.
Yep. Which,
does the team have any comments for that?
Yeah, I mean, we saw our largest gains in or just losses in HERS score mostly through our infiltration. So yeah, as the inner workings of REM rate are kind of a black box to us.
Yeah, to a lot of people don't. It's not
yeah. But yeah, it is a little black box, and I'm not trying to down on your modeling skills at all. Just curious. So, yeah.
Well, your double walls and triple pane windows, and if you got, passive house infiltration, probably pretty close.
Do you know what your infiltration was?
I believe we did the passive house standard, I believe is 0.6.
Yeah, that's wonderful.
Yeah.
We're almost at time. Any last comments or questions for the team?
No,
Can
nice
I buy
job.
it?
Yeah, nice job.
Milwaukee's a great place.
Okay, let's have a round of applause for our team.
Okay, I believe that about brings us to our lunch hour. So we will break for lunch in the cafe, and we will meet you back here at exactly 1 p.m. Mountain Time, 3 p.m. Eastern. Okay, thank y'all.